Ideas that we had in ME 218, and we have to review it. Anyhow, those 4 problems, again, finding the state of stress, but most of them are just a little bit more complicated than the one you have done in the past, but still is something everybody can manage. It's just the question of finding the state of stress in a rod or a beam under torsion, bending. It could be double bending, and we have discussed that all in ME 218. So those are 4. Then the next one is the subject we are going to discuss today and Thursday, and this will be going on for a week at least or more. And that is the beam design, not beam design, the deflection in a beam. And the first row or the second row here from chapter 9, which are the deflection of the beam, is about determinate problem. The last 3 are about the indeterminate problem, something which is you should get used to it, because you know from a static point of view, only certain problem you can find the reaction at the support. If the number of support exceed, let's say 2, generally you will not be able to find all the reaction by static alone. Everybody knows that. You need to have more than 3 equations, and you don't have in 2D problem. In 3D problem, you have only 6 equations, so you will not be able to solve those problems. For the first time, you are able to solve an indeterminate problem with the aid of a static, of course, first, and the strength of material. So quite frankly, if you ask me, everything that you were learning in a static and ME 218 is now you are getting to the real problem. The real problem is number 20, 23, and 32. Still, they are very simple version of it, but all the real problem in the world are indeterminate. So you cannot find any problem which is determinate, because already the solution is there. It's very simple. So the problem that in real scenario is indeterminate problem. Indeterminate problem, you cannot find a reaction. If you cannot find a reaction, you cannot draw the shear and moment diagram. You cannot do anything, actually. First, you have to get rid of the static. That strength of material, not 218, 219, come to your assistant in order to be able to solve those problems. You will see it when we get there. Not today, perhaps Thursday. However, we are going to go through the discussion. Now, what happened here is this. We are going to go and look at the beam one more time. So if you have a beam, please write it down now, the specific part of it. This is the beam. There could be any loading on that, this type or that type, or any type of loading. This beam, when you load it, generally go through this kind of deformation. This is exaggeration, of course. It goes down. It's not visible to the eye, so you don't see them, but it is going down anyway, yes or no? Now, generally, from now on, we are going to call this x-axis, and the other one we are going to choose, in other words, a center of coordinate. We put it at A and B. Now, this beam going from a straight line before the formation into this line, we call it after deformation. This, they call it elastic deformation. Elastic, because the beam is elastic. So sometimes they call it elastic curve or elastic deformation of that. And the question is, how do you present that? To present that, this, we call it a y function. Why? Because this distance from here to here is y. And as you see, y is not a constant. Y keeps changing from beginning to the end. Therefore, there is y to be found out as a function of x. If I can end up with a function of x for y, then I can calculate y at any point that I want, including y max. Somewhere is y max. Where that is depends on the beam and depends on the loading, of course. Is that correct or not? Then, of course, something else that first you cannot see it. However, it is there too. Look at this piece of the beam, for example, here. Notice that piece of the beam before the formation was flat, horizontal. After the formation becomes something like that. Is that correct or not? Therefore, there is a change in the slope. Here, slope is 0. Here, there is a slope like that. So if I bring that point down and show it like that, you see that there is a slope of theta. theta keep changing as well. Theta could be here, negative, could go with there. There is a theta that also can be expressed as a function of x. The question is, what is theta and what is y? We want to answer that question today. How do we calculate this, and what is the significance of them for solving determinate problem and indeterminate problem in particular? And by the way, y, the sign of it, if it goes down, is negative. Of course, as you see it here, this beam goes down negatively because this is positive y, and of course it's going down negative, and it goes up like that. We are going to call it positive. For theta, if theta goes clockwise, like moment, we are going to call it minus, and if it goes counterclockwise, we are going to call it plus. So this is our sign convention. Now, what happened in a beam? You have to understand that we discussed this long time ago in ME218. So when a beam is loaded after applied or M or loaded a piece of beam, if you recall, it becomes deformed like that, and it goes like that. This was rho. Remember the rho? The rho was called the radius of curvature. So, and 1 over rho was the curvature. So write it down, please. This is equation from ME218. In ME218, when you go to chapter 4, which was the stresses in the beam, we talk about the radius of curvature and the curvature itself. 1 over rho was m over EI, because the curvature of the beam depends on the properties of beam. If you have a beam and you bend it, if it is a plastic, it's easier bend than metal. Is that still? Because that depends on the value of E. And if it has larger cross-section, of course, you cannot easily bend it. Is that correct or not? Yes? So EIR comes into the picture. Then we do this. If you look at your handout, so go to your handout, the handout that I gave you for this lecture. There is a picture in front of it. I don't need to put it on there because you have it there. It's very simple. The equation has been driven there. No, after the shaft. After the shaft, no, go to the new handout that I gave you. Come on, guys, the one that you wanted to use last time. I have given everybody a copy of that one. Yes, do you see it? Yes, this one. Thank you. This is page, I don't know, you go here. Yes, this is the same handout. Yeah, it is after these 2 pages, correct. You can write your note, whatever I'm putting on the board, you can write it in your note or you can write it there. So I'm going to derive that equation very quickly for you. Let's assume we have here a beam like this. So this is before the formation. So let's show it with one line only. And if I put some kind of loading like that, pull it up like that, this is an exaggeration, of course, and let's say this was a fixed support. So this is going to go like that. Is that correct or not? Yes? So what we are going to do, we are going to take a section of that one like this, and this is going to call it delta x. And I'm going to show this one a little bit bigger in order for you to see. So we are going all of that. These are those lines that I show you there. So this is, we call it theta, and this is d theta, which related to this is from here to here is x. This distance is delta x. And if I bring this one, show it a little bit bigger underneath, it looks like that. So please write it down. Let's say this is O. And this is A. I believe in the handout I call this distance ds. ds, a distance from A to B, and this is a triangle there, and that is d theta. First of all, I can write in this triangle OAB, I can write tangent of d theta equal to d theta, because d theta is very small. Theta itself is small. D theta is much, much smaller, so I can do that. Tangent theta equal to d theta equal to ds, this length AB divided by that length, which is the rho. Or in other words, 1 over rho become equal to d theta by ds. So that's what we want. If I can write that, because 1 over rho is m over EI, so somehow this theta that you see there, or d theta that you see there, depends on the m and EI, because as the result of this force P, you are creating a m become something like that. Anyhow, then in order to solve the problem, we do it this way. First, we write it like that. 1 over rho equal to d theta divided by dx. I'm going to add it, divide that by dx. Then dx over ds. As you see, I have multiplied and divide this quantity by ds. So this is not in your notes, so you want to write it down for future courses, more advanced courses. So d theta over dx times dx over, all I did this equation, this is from this triangle. Tangent of this angle equal to ds over rho, yes or no? Then all I did, I divide and multiplied by dx. So now I have two quantities to work out, this quantity and that quantity, yes or no? Then I go to this little trapezoid shape there, and I show it a little bit bigger. That is like that. So it is generally, this is y, this is dx or delta x or dx, and this is y plus dx. Is that correct or not? Because y keep, as you see here, y keep changing too. So in this triangle, this line is perpendicular to the vertical line. This line is perpendicular to that line. Therefore, this is vertical line, that line. So this is theta, or a slope of the beam. So as you see, slope of the beam theta, that's the one we were talking here. That slope of the beam theta equal to what? Tangent of theta equal to dy over dx, because this is y plus dy. Is that correct or not? Therefore, in this side, I'm going to write this. Tangent theta equal to dy over dx. Is that correct or not? Remember, this angle is the same as this angle. Why? Because this line is perpendicular to that line, and this is tangent, because this is not drawn correctly. That should be perpendicular to that line. Is that correct or not? Yes? So therefore, that's right. Now, I do not theta. I need d theta by dx. Is that correct or not? So from this equation, I calculate theta. Theta become equal to tangent minus 1 dy by dx. Then I need d theta by dx. What I need here for the first quantity here, look at this first quantity, is d theta. So I need derivative of that one. So I have to take derivative of theta with respect to that, which is dx, d by dx of reverse tangent. Anybody remember from calculus what that derivative is? Yes?
1 over secant squared.
Something like that.
Yeah.
I don't remember. Do you remember? No, nobody should remember. In other words, that's what I'm saying. There's something nobody remember, and you should not remember that. But something like that. Is that correct or not? Yes, this is not a memory game. But however, you go to the calculus book, you find that this one, so I should give you the answer. The answer for that one is, you mean d2y over d2x squared, 1 plus dy, but maybe the shape when you see it will become a little bit something like that. Is that correct? And that is the derivative of tangent reverse. Is that correct or not? Anyhow, it's from calculus book. Is that understood? So this part, the first part, this part equal to that. So I have to put. Now, let's put the whole thing. Now, 1 over rho become equal to, by the way, equal to m over ei. First of all, equal to the first part. The first part is d2y over dx squared, 1 plus dy by dx to the power of 2. Let's leave it like that. Then multiplied by second part. What was second part? Second part was dx over ds. Yes or no? So let's put the dx there. So that's dx. But what is ds? ds, this is ds. Is that correct or not? Yes? ds squared equal to what? dx squared plus dy squared. So here, please write it down. dx squared plus dy squared. So if you take the dx out of here, you drop the dx out, this becomes 1 plus dy by ds squared to the power of 1/2. Everybody understand that? Multiplied by that one. Notice I can cross that and write it like that. dx times 1 plus dy by dx to the power of 2, the whole thing to the power of 1/2. dx and dx drops out. The total result, we get m over ei. which is the same as 1 over rho equal to d2y over dx squared, 1 plus dy over dx to the power of the 2, the whole thing to the power of 3, which is a differential equation. However, this is the general differential equation which is given in your handout. Notice in the handout, this formula is in your book. Do you see that? Yes? Do you see that formula? 1 over rho equal to, given in your handout. Do you see everybody? Yes? Mm-hmm. Correct. Now, for the purpose of this course, I said this, everything is very small, so you don't see here the theta or y. It is so small that we can say, since this is 1 and this is dy by dx is very small when it becomes a square. Let's say this is 0.01. When you square it, becomes 0.0001. Everybody understand that? So for the purpose of discussion in this class, those are called secondary deformation. We are going to, it has a sort of impact when we go through it. You probably realize that, which I'm going to explain to you later. But we are going to assume that is negligible or equal to 0. As the result, your equations end up what? This goes away. We don't care about that one. Look what you end up. You end up EI d2y over dx squared, EI times that, equal to m, but m must be expressed as a function of x. Is that correct or not? That is a simple, ordinary, second order differential equation. Yes or no? Yes? There is no other y there, so it is like what you have seen in the math. You write it like that. EI y double prime equal to a function of x. Is that correct or not? However, the whole idea is m has to be expressed as a function of x. Yes or no? Then how do we get to the y and theta? What should I do? What's the solution for differential equation? I asked you to study a little bit about differential equation. I don't think that any of you have gone and done it. Is that correct or not? Yes? Have you? No. That's the fact. I mean, nobody goes back again to the calculus, or you don't want that. But this is the simple second order differential equation. All you have to do the integration, simple integration. Is that correct?
Separable, right? Separable.
Yes, it is. It is function of x. This function of x is 2x to the power 3 plus 5, something like that. Is that correct? There is no y. We may go to the end of this course, we get to the problem with differential equation much more complex for buckling of the column. However, this is a simple differential equation. Everybody understand what I'm saying? That yes or no? To solve this problem, all we have to do the double integration. The first integration, write it down. This is the answer. The first integration will be EI dy by dx, which is what? What is dy by dx? Look one more time. Dy by dx is theta. Is that correct? The slope of the beam. You can write it like that. This is the integral of that one. Equal to EI theta equal to integral of mx dx plus a constant of C1. That is the equation of theta. So if I separate theta, divide this equation by EI, I have my theta as a function of x. But I have to have the m. Is that correct or not? Yes? And then later, you have to do one more integration. We call it this double integration method. So when you set up your equation like that, please write it down. This is very important. Aside from, this was the proof of it. Whether you want to remember it or not, that's not the part of this course. I show you how to do it in case in future courses you want to go back to general differential equation in very advanced courses, you go to that equation. We are neglecting this part. Is that correct or not? Then it becomes simplified version of that is this. So here is the first integral. On the second integral will give me the y as a function of x, because this is double prime, this is 1 prime, and this is y itself, equal to double integral of mx dx plus c1x plus c2. C1 and C2 are the constant of integration. Has to be, of course, like any other differential equation, has to be evaluated by we call it initial condition. Here we are going to call it boundary condition. Boundary condition or initial condition depends what kind of support you have. As I do the example, I'm going to explain you what kind of a support we have. It's very important. You have gone through a static. You have gone through a strength of material. You should know the significance of each support system. Everybody understands. Remember the support system we had in a static, a pinch support, a fixed support. Generally, we don't go beyond that. We have the pinch support, we have a fixed support, and we have a roller support, and also a bearing. Is that correct or not? Which you saw it in the shaft. Is that correct? So that's the type of support system we are going. In the beam, generally it is a pinch support or roller support or a fixed support. Anyhow, this C1 and C2 has to be determined from the condition, what kind of support we have. For example, let's look at this problem only. Now, what condition do you have here? Notice what is C1 and C2? Look, C1 is in the equation of theta. C1 and C2 are in the equation of the y. So any condition of theta and any condition on y is acceptable, yes or no? But for this beam, just for this beam, what initial condition do you have there, guys? Look at this one. I have a support here, yes or no? Correct or not? This support is not going vertically down and up. So the condition would be what? At x equal to 0, y become equal to 0. Is at x equal to 0 theta 0? Yes? No, it's not. If it was a fixed support, it would have been. Is that correct or not? So I want you to see the difference. For this problem, at x equal to 0, y equal to 0. Here at x equal to L, for example, whatever the length of it, again, y equal to 0, because you have to put two support there. If you have a beam like this, and you loaded that like that, obviously you cannot say anything about point B, because point B is going to go like this. Is that correct or not? Yes. So it goes down. It has a y at B. It has a theta at B. None of them are 0. But at A, sorry, at A, which is x equal to 0, y equal to 0, and theta also equal to 0. Correct or not? No, you are all quiet suddenly. Y theta equal to 0. You should know that. This is the one that bothers me a lot, and you have gone through the static class, and I have explained all of that to you, most of you that win in my static class. At least those people should be answering my question. So what I'm saying that is this guy. The beam, when it is a fixed support, why do you think you have a reaction here, M reaction? Because you are preventing that from rotation, Everybody understand that? If you have no M, this actually goes against each other. This has RA, therefore y must be equal to 0. It has an MA, therefore theta at that point must be equal to 0, because it goes flat, then it goes like that. Is that correct or not? Yes? However, look at the pinch support. At pinch support, look exactly like that. RA is there, therefore y. When this is there, this is 0. When this is there, this is 0. Is that correct? Because the M, you are putting enough M there to prevent that from the going through the rotation. Is that, if M is not there, then it was rotating. Is that correct or not? Look at this one. This is RA is there, therefore y equal, RA does not let this beam to go up and down. Yes or no? Correct or not? Therefore y must be equal to 0. As long, if RA is not there, then it is free. It goes up and down. Is that see what I'm talking about? It just goes hand by hand. Otherwise, we cannot solve all this problem. However, at this point, M is equal to 0. Yes? Therefore, theta is there. Is that correct? Theta has a magnitude because it's rotating this way, as you saw it there. Is that correct or not? You want to prevent that rotation, you have to put a moment there to make it 0, then it becomes a fixed support. Is that correct or not? Yes? And that's all. You had a question now.
Yeah, I was going to say, I just might remember my trig wrong, but instead of theta, isn't supposed to be tangent theta for dy over dx?
dy by dx is theta.
It's not tangent theta, it's theta.
Yes.
Oh, because I guess theta is small in this case.
Theta is small. That's right. Okay. Yeah, for theta very small. You will see that. This theta, you see, look at this beam. Every time you come in, you don't see the beam. Actually, that's just something I make fun of when you do the homework or quizzes. You come up with a deflection of 1.5 meters and theta equal to 20 degrees. So, oh, this beam is going like that. It is not. Yes or no? Yeah. So if it's the correct way, you are right. Absolutely right. That theta is very, very small. It's less than 1 or 2 degrees. Is that correct? You will see it on all our homework.
And that is going to be in degree. Is this theta in degrees?
It will be in radian. We'll get to that, all of that. Don't worry. The next is the example. So this is, we call this method, there are 4 methods we are going to discuss. This method is, it's not in the book in this format, so please write it down. Double integration method. Why double? Because you are starting from M. Sometimes we can start from W. I showed you that after I do a couple of examples. Is that correct or not? This is starting with M. So there are 2 integrations. One is theta. The other one is y. Is that correct? So the only boundary condition that you can use is theta and y. You cannot use anything else. There are other methods, there are other systems. We'll discuss it as we go forward. Now, let's start our first example here, which I did it for the other class. Might as well do it for you. So if you want to forget about all of this, that's okay. But all you can have to do is remember your static, which is your boundary condition, yes or no. And then your general differential equation, which is this one, the one in the box. Everybody see that? That is the start of every problem from now on, whether it's determinate or indeterminate. Good. So let's start now with one example while erasing the board. This is the simplest it can get, but it shows you everything that you asked. It was coming, but you asked ahead of time, all the sign, all the unit, etc., etc. And look at this problem now. Here we have a beam. Roller here, pin there is 10 foot long, and it has a uniform load of 4 kips per foot load. Obviously, this beam is determinate because immediately I can find reaction. This is such a simple beam, you don't even have to think about it. It is a symmetrical beam, so the RA must be equal to RB. So let's say that here is A, and here is B. So the static of this problem, it's very simple. So 20 times 4 is 40, half and half, so 20K here. 20K here. These are the questions you want to answer. Given E equal to 29 times 10 to the power of 6 psi, and given I of the beam could be any cross section. Remember, it could be wide flange beam, it could be square, it could be rectangular, or whatever. That's beside the point. Is given 50 inch to the power of 4. Notice usually we do it in this system. This is in inch. Notice this is in foot. So please, when you see that, do not go change to inch. That's bad. And more importantly, do not go change this to foot to the power of 4, as a couple of you did it in some of your quizzes. That's a no-no. Absolutely not. You never change the data that is given. You carry it exactly the same. The adjustment comes at the end. Everybody on anything else you do is incorrect. Why? It is common practice. What I'm showing you is the common practice. You go to the Home Depot, you want to buy a pipe. I asked you, I believe I mentioned it last time. When you want to buy a pipe, you say, give me a 12-foot or 6-foot pipe, yes or no? So it comes in foot. But when you want to give you dimension of that pipe, you don't say it in foot. You don't give me a pipe of 0.25 inches, foot. Is that correct or not? You say 1 inch, quarter inch, yes or no? That is exactly the way it should be carried. This is the very practical format of it. This is in pound per inch square. This is inch, but this is in foot. Keep it as it is. You will see how I handle the unit at the end. Is that correct or not? Please make a note of that. Do not change this. I have never seen, for example, some people even come to pound per foot square. I have said in one of my classes, I say it again, if you find unit of stress in pound per foot square, I give you A for this class. And I change your grade for 218 and static to A as well. What I'm saying that such a unit doesn't exist, everybody. That unit is only for pressure. The pressure, you say pound per foot. But stress, as long as the stress analysis go in all over the world or every book, it is either pound per inch square, which is PSI, or KSI, which is 1,000 pounds per. There is no pound per foot square as sigma. That's not unit, never used it. You know, you can use it, but I never use it. Is that correct or not? It is unheard of. It's nowhere in the book. The pressure can be expressed pound per square foot. That's a different thing. Is that correct or not? Or Pascal or megapascal. Those are the only units we have. Is that correct or not? Or kilopascal or mega. Nevertheless, be careful of what I'm doing there. Now, saying that, we want to calculate theta A. This is the question we want to answer. And we want to calculate Y max, for example, for this beam. Significant of that comes later on. Okay, immediately I have to start with my differential equation. So what you need really is not the differential. You are going to use that enough time in this example that you get bored and sick of this. Is that correct or not? What is important for me is not this. It's writing moment as a function of x. Something you try to do it in ME 218, and I ask you, please do not do it. It's not for the purpose of drawing the shear and moment diagram. It's for the purpose of today's lecture. Everybody understand that. The reason in ME 218, sometimes your instructor were asking you to write your shear and moment diagram for today's lecture. Now you should be all good at it, in other words. How do I write that one? Look what I'm going to write here and tell me whether this is correct or not. dEI d2y over dx squared, which is y double prime, equal to m as a function of the x. I look here and I put 20x minus 4x squared over 2. Is that correct or not? And you have to be as fast as I am. Don't tell me now. Now, of course, you are not today. Everybody understand that. Everybody see that. However, after you do the first 2, 3, or 4 problems, you say, oh, this is the routine. I'm going to get hang of it. Is that correct? And do it quickly. Did you understand what I did? Anybody can help me to set it up without doing any?
Sorry, that's 20x, correct?
Yes. Sorry, if it doesn't look like x. Must be as a function of 20x times 4 times x squared over 2. How did I get that? No idea? Okay, you have to cut here. First of all, didn't I say you call this one x and this one y? Yes or no? Or w or m or whatever you are. You call this beam at a distance of x. Isn't that what you have done in the past? Correct? Actually, we did it at the beginning of the class. Come on, guys. Okay, here it is. This is 20, yes or no? And this is the load. This is free body diagram of the left-hand side of this beam. Is that correct or not? Then, what is inside the body? Inside the body of the beam, here, inside the body, there is a shear and there is a m, but it is a function of x because there is no distance of 2 feet and 1 foot. And x changes between what? For this system, x changes between, can I write one equation? Remember, we have this also in the past. Can I write one equation for entire beam? Yes, because the load is constant, shear is linear, moment is a parabola from beginning to the end. Yes or no? You have seen it in all your homework. When this is constant, the shear is linear, the moment is a parabola. Yes or no? Correct? Therefore, I can write one equation for x. This changes quickly. X between 0 to 10 for entire beam. Is that correct or not? Because I have only one system of load. Everybody getting the point? Yes? Therefore, this becomes x. The rest is static. Yes or no? I said it 100 times. This is static. Everybody should have been doing it before. And this is now, you take not the moment about point A. You take the moment about the cut. Yes or no? So if you take that summation of the moment about XX section equal to 0, or you can call it AA section, or XX section, whatever is your choice. Everybody understand that? Or AA, I can change it to AA if you want, for the left-hand side. Then as you see, you have 20 times x. It's going that way, it's negative, yes or no? Correct? Then you have this load. What's that load equal to? 4 times x. So you put 4x and you put it at the middle because this is rectangular, yes or no? So it is, the load is 4x times what distance? What is this distance? That distance is, you have done it in the past, you just didn't pick it up quickly. So time x, and the moment is also is positive, yes or no, correct? And plus what? Plus, look at mx. Mx also going, you have to draw mx this way. Never draw it other way. If you do it other way, you are wrong because you are assuming it is negative. You always should assume it is positive. Plus what? Plus mx equal to 0. As you see, mx end up to be 20x minus 4x squared. How did I do it? I look here. I said here the action is negative. I want the reaction, so I put here 20x. You should do it like that. This action is 4x times x over 2. The action is positive. The reaction of the beam to it will be negative. You can go this way, you can go that way, whatever you choose. So if it is the beginning, you can always draw a free body diagram. After one time, twice, 3 times, 4 times, this is the same routine, so why not I use this the same way? Is that correct or not? Yes? Everybody with me? It's very simple. So that's it. That is your differential equation. Notice EI y double prime equal to this function. This, the rest is like math. Is that correct or not? The math part of it doesn't get you any point. When we come to the quiz, don't accept, I said you write 4 or 5 lines. Believe me, you are going to write this in every problem, not once, but twice or 3 times for every problem. There are 10 problems there. By the end of the discussion, 2 weeks, you're probably going to do this at least 100 times. Is no credit there because it's boring. Is that correct or not? It's just what is important, writing your M, applying your boundary condition. Everybody understand what I'm saying? That. Nevertheless, let's do it. EI dy by dx, which is the same as saying EI theta, this is the one you questioned there. Is that correct or not? Equal to 20x squared over 2 minus 4x3 divided by 6 plus C1. Now a discussion here. Something very important that you don't see in the book, but you have to pick it up. What is this? This is mx, yes or no? Yes, this is m. What's the unit of m? What did I use here? What's the unit of m? Is Kip's foot. So this have the unit of Kip's foot without you realizing is what. That's why I'm asking you, if you see this 4 and this 2, do not divide these 2 by each other. This 2 is a scalar number. This 4 has a unit in it. Everybody see that? This is W and this is R. Is that R? Guys, is this come from R? Yes or no? Actually, this is RAX minus WX squared over 2. Is that correct or not? Yes? These are different numbers with different units, but the whole equation has a unit of Kip's foot. It has to be because it is more m. Look at this. Kips times length, yes or no? Look at this one. 4 kips per foot multiplied by foot squared. The result is Kip's foot, yes or no? Correct? Now, what's the unit of this one now? All the number here. Because I integrate that over x. So what's this one? What's the unit of that one? Look, one more x. Is that correct or not? Absolutely. So it will be what? Kip's foot to the power of 2. Correct. So C1 has a unit. So that's why I try to keep this. Please remember this. I'm giving you this because this was my expertise when I was young. I was working with this system many, many years. So try to write programming for this system. I try to work for IBM, etc., etc. So I know a little trick about this. So please listen to me carefully. It is a little bit different from the book, but it makes things a little bit simpler. Everybody understand as far as the math is concerned. So there is a free trick which we have to use it for programming purposes. Why not using here? I never divide these 2 by each other. You will see in a minute what happened next. So EI y become equal to 20x to the power of 3 over 6 without dividing these 2 together, minus 4x4 over 24 plus C1x plus C2. Do you see the routine here? X squared divided by 2, x3 divided by 6, x4 divided by 24. What will be the next one? x5 divided by what? By 100? 120. Why? That's absolutely correct. Why? This is the format there. If you are writing in this format, you can program it later on. Look what it is. This is factorial. So please, this is something you have to bear in mind. It's not mentioned in the book. I don't know, maybe it's somebody is mentioning it. All this format, if you do not divide this, if you divide this, this format collapses. Is that correct or not? Everything is in the format of xn divided by factorial. So it doesn't matter. Here is 1, this is 2 or 3. So you can program that for computer. Some of you are good for computer programming to go to the lib n equal to 1 or 2 or 3 or 4 or 5. So take care of the whole thing. Is that correct or not? This is the system you should use for your homework as well. It becomes much simpler. You will see in a minute. So therefore, never change the unit. Keep it like that. So this is put to the power of 2. And this one will be put to the power of 3, of course. So every number here of the whole thing, every quantity here has the unit of kips put to the power of 3. Is that correct or not? Some people even suggest that you should use this as RA and this W, not to mix this W and 24 together. Is that correct? But W was given, so I used it. Is that correct or not? Yes, this is W and this is RA. Is that correct or not? Now here is our integration. Now what you want to do, calculate C1 and C2. Look at that one. At x equal to 0, then y equal to 0. Because I see a support here, I see a reaction here. That reaction causes no movement in the y direction. This is the way you learn static. Is that correct or not? If this RA was not there, this would have been free. You wouldn't have any boundary condition. Is that correct or not? Yes? Are you with me? Yes. So x equal to 0, y, which you have to put it in this equation, not because this is equation of theta, this is equation of the moment, this is equation of the y. Is that correct? In that order. As you see, theta equal to this divided by EI. Actually, I'll do it later on when I finished it. So at x equal to 0, y equal to 0, so you go to that equation, 0 equal to 0 minus 0 plus 0, C1 times 0 plus C2. This becomes 0, 0, 0. Therefore, C2 must be equal to 0. This is always the case if you have a reaction at the beginning. So C2 disappear or go to 0. Now, in order to calculate C1, I cannot say the same thing. If theta was here 0, then I would say, OK, 0, 0, 0, C1 would have been equal to 0. But it is not. What boundary condition do I have now here? I have at x equal to 10, y equal to 0. Yes or no? Correct? So let's use it. The second boundary condition is here, as you see here. At this point, x equal to 10, y at b equal to 0. Yes or no? Is that correct? Because you have another support at this end of the beam. Correct? So in this equation, you have to write your system there. So I'm going to use this side of the board for you to finish the whole thing. So therefore, here we go. So again, you write 0 equal to, because it is 0, 20 times 10 to the power of 3 divided by 6 minus 4 times 10 to the power of 4. Notice I'm using the same format. Nothing has changed. Divided by 24 plus C1 times 10 equal to 0 because C2 disappeared. Is that correct or not? Yes, I plug in this equation, x equal to 10. It's really simple. All you have to do, plug in either this equation or that equation. In this case, we only had the y. We had y and y, so we have to use this equation. This is not no use. However, I can calculate C1 from that equation. Yes or no? C1 ends up, you just calculate that, you drop one of the 10, you get a common factor or whatever you do. Be careful not to make any mistake. So C1 ends up to be equal to, for this problem, equal to minus 167 kips foot square. because you are here. C1 has a unit of kips foot square. Correct or not? Yes? Okay. This is now the equation of theta. Now finish. Theta, if somebody asks you, give me the equation, sometimes your homework reads like that. Give us the equation of theta and y. Is that correct? Theta equal to, from this equation, theta equal to this divided by value of EI. So 1 over EI, multiply that, you can write it like 20 x squared over 2 minus 4x3 over 6. Notice automatically without C, I put 6 here, plus C1 or minus 167. This is the equation of theta. And equation of the y is 1 over EI, 20 x3 over 6 minus 4x4 over 24 minus 167x, and the value of C2 was equal to 0. That's the equation for y, correct? But that represents entire theta from the beginning to the end. Is that correct or not? Now, what the question you want to answer depends what they are asking you. Sometimes they ask you to do it here. Sometimes they ask you to. What did I ask you to do? You wrote it in your note. What do you want to do? Theta at A. At A, x equal to 0. So here is the rest of the problem. This, you put it in the box. This is the goal. We achieve our goal. We find the theta and y. Notice ME 218 was limited to shear and moment. Now we are going at more. Now we are talking about theta and y, which is the continuation of integration method. Is that correct? Yes? So therefore, this is the fact remain there. However, if I want to calculate theta at A, at x equal to 0, the question is, what is theta A? Is that what you want to answer? In this equation, you have to put x equal to 0. So you put x equal to that. So theta at A, you can write it like that, or however, become equal to EI remain there, because EI, then 0, 0, 0, so minus 167. Is that correct or not? If they don't give you the EI, you leave it in this format. Many homework are like that. But some homework that I picked up, you need to go to your numerical format of it. Give me how much is it. It is 1 degree, 2 degree, 10 degree, whatever it is. Is that correct or not? It should come up with a very small angle, yes? Mm-hmm. Okay, now how do I do that? This is what I want you to practice on this one. Please do not miss this one, okay? This is the one that everybody has problem with. So I don't know, suddenly you decide. This is the E and this is I. Now look, I'm going to put it exactly the same way it is there. Theta A, this is very important, equal to minus 167 kips foot to the power of 3. Yes or no? This is different from the book, or I don't know if we use it the same thing or not, but I don't know. But I'm suggesting all of you follow this routine. Notice I did not change those to foot to the power of 4, etc. I'm going to use it as it's given to me. How much is given to us usually? 29 times 10 to the power of 6, yes or no? Pound per inches square. Is that what PSI is? Yes or no? Times what? Times 50 inch to the power of 4. So the result of this and this together obviously has to be pound inches square. Yes or no? Mm-hmm. Yes? Which is very similar. Otherwise, it is not wrong. But one is in pound and inch. The other one is in kips and foot. So all you have to do now, make the conversion. Yes or no? If I want this to be pound, what should I do? I multiply that by 10 to the power of 3, because 1 kips is 1,000 pounds. So therefore, you like that, 10 to the power of 3. So that becomes pound foot to the power of 2. Now, each foot equal to how many inches? Each foot equal to 12. So you multiply that by 12 to the power of 2. So this becomes pound inch to the power of 2. This and this drops out. So it is, that's what you were asking. So it is no unit there. It will be in radian. Yes or no? Correct or not? It's not in angle. So theta A, when you finish that, this is it. This is all the conversion you need. If it is kilonewton, you put K there. It is meter or millimeter, you put it there. Is that correct or not? So you make the conversion right there, not at the beginning. Because remember, if you change this 10 foot to 120 inches, look how big this equation goes. Look, and then you lose track of everything. Everybody understand? Or in the book, always the i's are in inch to, all the table I gave you, all the i's were in inch to the power. They never was in foot to the power. As I said, you never see that unit. Is that correct or not? Yes? So therefore, why not follow the routine? This is the routine. Nevertheless, theta A, making the story short, become equal to minus 0.0166 radian, which is multiplied by 180 degree divided by 3.14 to be, you want to minus 952.95 degree, less than 1 degree for this beam. Now, this theta is positive or negative? This is theta A. This theta is positive or negative? Earlier discussion. This theta is negative. This theta is? No, be careful. It's not negative. It is the same because it is symmetrical. So I have to be very careful. But that theta is not negative. That theta is positive because notice that it is symmetrical in the scenario that this theta equals that theta. But this one is going counterclockwise. This one is going clockwise. So actually this theta, remember that for other method that we are going to discuss in future. These theta are equal. One is positive, one is negative. Yes or no? Now.
It's only symmetrical. It's only because it's symmetrical. But if we don't have a symmetrical system.
Then still one is negative, one is positive, but it will be different angle.
Yeah.
We get to that. Next problem is like that. Is that correct? This is symmetrical. They are equal, but they have different sides. Is that kind? Like a shear diagram. A shear diagram has different sides. It's not like moment diagram. It's very interesting. They all come together one after another. You will see the same pattern. Is that correct or not? Now, next thing is calculating the y. By the way, since this is symmetrical, theta at the middle must be equal to 0. Is that correct? Because it has to be flat. Is that correct? But some people use that as a condition for solving the problem. And second part is that what do you want next? You want to calculate what? Y max, which is at the middle. It's where the moment is maximum. Is that correct or not? When M at the middle is maximum, so everything else becomes maximum, so you calculate Y max. Is that correct or not? There is something else that I can tell you mathematically. When theta equal to 0, M is equal to maximum. Is that correct? Like a derivative. Is that correct? Remember, the derivative of Y is theta. Is that correct or not? Theta as the middle is 0, therefore M must be max. Again, remember the shear diagram and moment diagram? Because each one is integral of the other one. The same formula of integration works for you guys. Is that correct or not? Don't be surprised. That's the same thing. So next question, we want to calculate Y max. Y max is at the middle, yes or no? So I have to calculate at x equal to 5. That's right. So Y max is equal to, again, EI goes there. Then I have to this equation, put x equal to 5, which is 20 times 5 to the power of 3 divided by 6. And then minus 4, 5 to the power of 4 divided by 24. And minus 167 times 5 divided by EI. When you do that, this time this becomes equal to minus 522.5 divided by EI. Using the same method one more time. Y max become equal to minus 522.5 divided by 29 times 10 to the power of 6 psi multiplied by 50 inch to the power of 4. So therefore, the unit is pound inch to the power of 2. Yes or no? Correct? For denominator. For numerator, the unit is not Kip's foot to the power of 2. It is Kip's foot to the power of 3 because we are one more integration above. So since this is Kip's foot to the power of 3, you multiply that to the 10 to the power of 3, so that becomes pound. And you always measure your deflection not in foot. You always measure the smallest quantity that you can have. Here is inch or millimeter. Yes or no? Therefore, you multiply that by what? By 12 to the power of 3. So the result will be pound, inch to the power of 3. Pound and pound drops out. This and drops out. The y will be in inch. Is that correct or not? So that is the system we are going to use. Hopefully you followed that. And that becomes minus 0.623 inch. You had a question there somewhere. Yes. I answer you. What? What did I make a mistake there? This one? Y max here. 500. I got 522.5. Okay. No, 10 to the power. Is that what you are saying? 10 to the power of 3? That what, because this is Kip's foot to the power of 3. Is that what you are talking about? Yeah, I changed the Kip's to the pound. I multiplied that by 10 to the power of 3. If it was originally pound, it's given in the pound per foot, then you use it that. But I use Kip's per foot, yes? 10 to the power of 3 changes the Kip's. Oh, that's what I erased that. So this is what I put here. One more time. It was Kip's foot to the power of 3. This you multiply by 10 to the power of 3, so it becomes pound. Is that correct? And this you multiply 12, so it becomes inch to the power of 3. Is that correct? Yes. All right. Anyhow, so that's the answer. Now I have about 5 minutes for the other class. I was able to do another problem, but I'm going to mention it, but I don't have time to go through detail of it. It's very important right now. From so far, you can solve this problem and all this problem. But let's change this problem to the following problem and tell me what you are going to do. So be careful because you have to do some of your homework if I were you, because there is so much coming again, new material. You want to get ahead of everybody else. You should be able doing this problem before Thursday class. This homework is due next Tuesday, by the way, everybody, and until I finish the subject. Is that correct? Now, here is the beam, the same beam, and here is the same, except this is the load. This is the 4 kips per foot, the same unit. This is 5 feet, and this is 5 feet. This is point A, this is point B, and this is point C. Can I use that technique here? Of course, yes, but with some modification. What is the modification? Moment equation is different. That's something we learn in ME 218. That's the whole thing. The moment equation between A to C is totally different from C to B. So I call this as if it is 2 problems or 2 different regions. So it's like getting a metro ride, and suddenly at the middle of the metro ride, you have to change your metro, going from yellow line, I don't know, from red line to blue line, or etc. So I'm going to use the same color purpose. Look, this beam is going to bend something like that up to that point, and then the area from C to B gets a different format, but this is different curve, different Y, but it goes maybe going down here. I don't know where the maximum even is, and goes like that because the load are more to the right, so it is going like that. So as you see here from previous experience, you know that AC is no load. The shear diagram is a constant. The moment diagram is a linear, yes or no? And this part is reverse. Is that correct? Because this is constant, the shear is not reverse, I'm sorry. The load is constant, the shear is linear, the moment is a parabola, yes or no? Therefore, this has to be set up in 2 systems. Is that correct or not? So let's do primary part of it. X between 0 to 5, or the purple area. Is that correct or not? Which gives me this, we call it Y1. Y1 only goes from A to C. Everybody understand that? Then you have to set up this. In other words, that setup that you see, I have done it for the previous problem, which was 1 setup. Here become 2 setup. That's the only difference. With one big difference between the 2. Here, X changes between 5 feet to 10 feet, because that's the only region I can use that, and that is the red Right. Now you have to write two set of equation here. EI d2y over dx squared equal to mx for the purple area. Yes or no? Here you have to write EI d2y over dx squared equal to m as a function of x for the red area. Yes. Is this the same as you all suggested? Is not the same. Is that correct or not? Yes? I'm going to put that here, and you just check it for yourself. This one, first of all, this is 4 kips. This is 5. It's 20. How much of it goes there? How much of it goes there? How much of it? It's there. The load is here. 7.5 to 2.5. So here goes 15K with the same ratio. Here goes 5K. You can check that at home if you want. Is that ratio 3 and 1? Is that correct or not? Yes? So for this one, I will write EI d2y over dx squared equal to 5x only, nothing else. Is that correct or not? Yes? For that one, I will do it next time. But what I'm telling you, because I'm running out of time, I don't want to take more time of your time, but you have to be careful. At x equal to 0, y1 equal to 0. At x equal to b, y2 equal to 0. Then you have to set up something here, because this is a common thing in here between. We are going to do that. However, for problem number 9, I think the second problem is number 6. They give you something like that. They give you a load like that, and a load like that, a load. This seems to be this system. However, if you read the question carefully, they only want the deflection at point B. They don't want the deflection at point C. Since they don't want them, you can bring this, all of this here, everybody, and add a little bit moment to it, and do it as one part. So please do that. You can do problem number 3, 6, and 9. But these are a little bit more complex. You have to use this technique, and I'm unfortunately behind. But I'm going to show you how to do it on Thursday. Sorry, we have to catch up with the other class, so we get there.